Hi, I'm Brian Nolen with Indu-Sol America. Thanks for joining us for the next edition of Tech Talks. I'm joined today by Paul from our German team, Product Manager Paul.
Hi, nice to meet you, Brian.
Yeah, thank you for joining us today.
You're welcome.
Yeah. So oftentimes what we see in US production is that when production issues occur, the assumption is that the fault lies in the hardware, the PLC, perhaps a software issue. And ultimately, the root cause is an underlying network issue, which can be difficult to troubleshoot until a shutdown occurs, and then it's a guessing game, right?
Exactly, and often then that's too late, because then you are under pressure. You have to find the issue. The problem is that this is what the operator or the maintenance guys can see from the PLC. The PLC does kind of monitoring your application, your Profinet or Ethernet IP, for example. But it only looks for, are the devices communicating, but not how good. And that's the point. Then it only tells you, now it's too late because they are not communicating anymore.
Okay, so is it possible for the maintenance teams to get a warning before a shutdown occurs?
It is possible because basically all the industrial protocols have built in some diagnostic features. Some more, some less. But it is, and that's what we are doing since 15, 20 years. You can compare it to the traffic. Yeah? If you know traffic lights, they are not switching from green to red immediately.
Right.
This would be bad, right? Because you would have a lot of crashes. Yeah? They are turning into yellow, into a yellow state that it will be changed to red in some seconds. And same we could do here. We could show that there are issues and you have to investigate those issues, otherwise you will have an intermediately stop of the machine.
Okay, so it's possible for the maintenance teams to get a yellow warning before a shutdown occurs so that they can do predictive maintenance instead of reactive maintenance.
Exactly, yeah. And also for the troubleshooting, it's easier. Yeah? If you look, I have an example for you. Yeah? You see, you have a network structure, very easy network structure. The situation is that your device number 12, that's this one, the last one, over the day it had 2 failures. And then the operator had to acknowledge the error and he could restart the machine, it was working. Then sporadically, again an error. Same device. Yeah? That's the situation. And of course, the first thing maintenance guys are doing is they are checking here for the error, because clearly if this device has a failure, maybe it's the connection to the device, or maybe, as you said, the device has a hardware issue or something like this. And then it will change. And it's a try and error. What we can do now is we can give them the additional information about missed updates. Yeah? Often PLCs accept missed updates until a certain point. But if we measure those missed updates, we see, it's also this device which had the most, so it is affected the most. But clearly also all the other devices here are affected. And then with the first look, you don't have to investigate here for the issue, because the root cause of the issue is here, situated here in this location.
So oftentimes the first device that fails is not the root cause of the problem.
Exactly, or the root cause of this problem is not located at this device. Because often devices are configured differently. You can see it here, for example. The device number 12 has the biggest packets, the biggest telegrams, and it sends with the fastest update rate. That means you have big packets and a lot of big packets, so the possibility that a sporadic issue hits such a packet is way higher than for such devices which have small packets and which are sending way slower.
Okay. So I see we have a missed update on switch 2. Would then that logically lead your troubleshooting team to locate that area as the potential problem area?
Yeah, exactly. So the benefit for the maintenance guys are just to see which devices are affected and where are these devices located.
Okay.
And then they know, okay, we have to check here in this area and not here.
So what kind of tool can we use to get these type of updates.
There are different ways. So we have, for example, the inspector, we have the agent blonde. There are different possibilities to check for the quality. Important is that we are measuring permanently in the best case.
Right.
Because, as I said, often these are sporadic issues. And if you then to a reactive maintenance strategy, you have the problem that when you measure, it could be everything okay. And then you will not find the error. So that's why permanent monitoring is very important at this point.
Okay. And what about during commissioning? A lot of issues arise during commissioning, and this can also be a problem.
Same there. Basically, we have two stages. First is the commissioning, where we have a lot of errors. That's why we have the commissioning phase. And we will have to fix these issues. For example, cable and connector problems with a bad wiring, and then we have to rewire the connector, and then it will work. That's one case, and the other case is with just aging of the machine.
Sure.
After 15, 20 years, because industrial machines have to run for 15, 20, even more years. And then aging begins, wear and tear, and then we have to renew components of your machine.
Okay. So with the right condition-based monitoring solutions, you can avoid downtime.
Exactly, because you know where's the issue, you will see the issue before it comes to a breakdown. You can plan for maintenance works, for renewing components, and then you could plan it, you have no sporadic downtime.
And are these strategies easy for maintenance teams to absorb and pass on the information?
Yes, because all they need to know is when the yellow state occurs and which devices are affected. And then they can change the cable, for example, because most of the problems are physical problems, especially cables and connectors.
Great, so it looks like here we have a strategy that will allow maintenance teams to react, to perform preventative maintenance so that breakdowns don't occur, instead of doing reactive maintenance, which is ultimately ends up being a guessing game of troubleshooting.
Exactly. And that's the benefit. That's why we measure the quality, and not only if there is a communication, but how good is the communication.
Wow, those are some great insights, Paul. Thanks for joining us for this edition of Tech Talks. To learn more about Indu-Sol's condition-based monitoring strategies, feel free to reach out.